everyone. My name is Suze Pathmanathan and I'm the host of today's webinar. With me is Epco Berger.
Yeah, thank you. Yeah, my name is Epco Berger. I'm the Managing Director of Totalite and we're joining this webinar.
Okay, so starting from the beginning, I'm curious as to why Totalite was created.
Totalite was created for a few reasons. What we observe is that there all across the world, there's aging infrastructure. So a lot of infrastructure has been designed and built after the Second World War. And in the meantime, that is 50, 60, 70 years old. And that is a significant part of infrastructure that we have in the Netherlands, in Germany, US, all around the world. That means that for infrastructure that's designed for maybe 100 years, but some of them 50 years design life, is getting at end of life. So there needs to be monitoring to help decisions on where do you spend your money in renovation, complete rebuild, or what infrastructure can still be, well, the life can still be extended with a little bit of maintenance. To make that decision, you need good insights that can be done with monitoring, but that then needs to be in a scalable manner. The second thing that we see is that construction sites and projects are getting more complex. So there's a more densely built environment and regulations are getting tougher or more stringent. So that also is forcing construction projects in more monitoring. The third one, where both of them are actually requiring more monitoring, we see that a lot of our customers are having difficulties finding resources and the skilled resources, so experts can actually do this job. And if that's not there, then you need to have a different way of making that scalable. So having learnings of the experts included in products that can then be handled by people that maybe have slightly less experience. So Totalite is designed for having the accurate data that you need for monitoring in as simple as possible manner. So it actually saves you man hours and you don't need all those experts that you might not have in your team.
How easy was it designing a product like this for the market where you've got a mix of people that know technology versus people that, kind of new to the industry, say?
That was hard. Well, first of all, we had to make sure that the product's actually doing what it should be doing, because monitoring projects, they have their specifications. So you can make a super nice looking product that's easy to use, but if it doesn't deliver the accuracy that's needed in those projects, we would not have a product. Yeah. So on the one hand, to make sure that we reach that stage of millimeter accuracy, that was already hard. But on top of that, having that accuracy and then having the simplicity in usage and the difference in type of people, we actually made a choice that we said, if we design it for the ones that are have less expertise, it becomes easier and it saves hours also for the ones that are experts. So if it works for somebody less expert, then it eases the life of the experts as well.
Yeah, for sure. Is it almost a sense of too good to be true as well? I mean, right now, I think we're also educating the market on the advantages of continuous monitoring versus periodic monitoring. A lot of people have viewed continuous monitoring previously as a bit of a luxury or nice to have, and it's been something that they couldn't really afford to implement. What are the advantages, and how does our product democratize this technology so that people can use it?
Yeah, good question. So I think in the space where the infrastructure is aging, maybe that reference to periodic inspections, I think that has been very, very good process and approach for years. I mean, if you have new infrastructure, then having your periodic interval is more than enough. And for many applications, it still is. But now that infrastructure is aging, and construction projects are becoming more complex, you need a higher frequency. And then to a certain extent that you actually want to know it continuously. Why? Because infrastructure and buildings, they have a movement trend. Everything moves all the time. Day and night rhythms are there because of temperature. There are seasonalities, winter versus summer. So everything moves. And before you can actually make a judgment whether something moves and the movement is dangerous or requires attention, or a movement is okay because that's the standard trend, you're only going to find out if you have continuous monitoring. And what you see happening is that quite some of our customers actually advise the end client, let it run, for 2 weeks, 3 weeks, and only then define what thresholds we need to set on the alarms. So only then we know what pattern is a normal pattern. So that is where continuous monitoring makes a huge difference compared to periodic, and what is really needed today. The other thing, what we designed for, as said, is to make it as simple as possible. So there are already continuous monitoring systems on the market, but they are require quite some expertise, are really expensive, take a lot of time to install and get data flowing, and we aim to simplify that so that it's costing very, very limited time. So you save man hours in the project, you save costs on equipment. You don't have to go back on site. It does not need to be recalibrated. So it's calibrated in the office before it leaves our facility, and then is calibrated for the lifetime. So everything we have done is aimed at creating efficiency and scalability.
So that was a great answer, Epco, and a great intro. So with the next part of the webinar showcasing the real world setup of the device via ILI, can you take a moment to explain what customer pain point we're aiming to address with this webinar?
Yeah, absolutely. Yeah, so what we noticed is that if we explain the product, the benefits of it, and also ILI explains how the setup is done in onboarding, just prior to that, from the demo from business developers, most of our customers do acknowledge that it's really easy to set up and then wait until the project comes. And then the project typically always comes with urgency. So there's no project for a while, and then once sudden it's there, and it needs to happen fast. And there are a few things with the Totalite that is slightly different than how our customers are typically used to install a total station. And I just believe that instead of having that conversation all the way at the end, last moment, I think it's just worthwhile already running through how such a setup in the real world looks like and what are the things to think of. It is easy, it is fast, but what do you need to think of? And I'd rather explain that up front as a team than at the moment that time is really short and then time becomes really urgent. So that's what we try to do here, helping our customers to really understand what steps to take in installing it and easing their project if it comes.
Makes sense. Very efficient. So without further ado, we're on to ILI's part of the webinar now, where he's going to show us how the device is set up, show the app wizard as well, and walk through exactly what you can expect from unboxing to monitoring when you're setting up in an hour.
Hey everyone, thanks for tuning in to our webinar. My name is Ili, I'm Customer Success Manager at Totalite. And in the following video clips, I will be walking you through the installation steps and best practices for Totalite sensor, how to get you set up with the app wizard, and how to get you set up with the Totalite platform, including setting up the baseline and all of the unique features that Totalite platform offers. Totalite installation, the first step that we have to do is to get credentials to the Totalite platform, log in, create a project, and assign the sensor to the project. So I am already logged in, and I will create a new project right away. I'll give it a name. For example, Notedorp Garage Testing. I will select the sensor that I want for the project, which is Totalite 77392, and I will click Create Project. And at this point, the next step is on-site for the sensor and the target mounting. So I'll see you on site. All right, so now that we are on site, we really want to get a hold of our monitoring setup. In our case, we will be monitoring this parking garage and the steel beams that are holding it together. And normally the first thing that I'm going to do is I'm going to install the targets. In our case, we will be using standard L-bar prisms as our monitoring targets, and we will be installing them with a magnet. We advise for you to actually drill them to the structure you want to monitor for better robustness of the installation. As well, when installing the targets, please keep in mind to respect the 2-degree angle separation. So don't install too many targets too close together. When installing the targets, make sure they are rotated to face directly the Totalite sensor lens. When installing the reference target, make sure it is outside of the zone of influence. It's rigidly installed, and you only have the need of one reference target. More reference targets will not create an advantageous redundancy. The only time you need 2 reference targets is when your sensor is going to be mounted with more than 20 degrees of tilt and pitch or roll. Once we've installed all of the targets, make sure that they will be facing directly the Totalite sensor lens, and all of them are meeting the 2-degree target separation criteria. We can go ahead and mount the sensor. As a first step for the installation and mounting of the Totalite sensor, we need to secure the power adapter and the power source. In our case, we were lucky and we had a wall plug just behind me. As a next step for the mounting of the sensor, we need to secure the bracket. In our case, we will be using a Totalite bracket with a very strong magnet that is attached to a steel beam. Our advice is, when possible, to drill the bracket to a secure structure such that we are not allowing for any translational movement of the bracket and the sensor that will be mounted on the bracket, due to the fact that the sensor is not compensating for translational movement, only for rotational movement. When securing the sensor on the bracket, please make sure that it allows for the field of view of Totalite to see all of your targets from your monitoring setup. When connecting to power, make sure that you are using both connectors for M12 power and M12 shield with the splitter. One side goes in the shield and the other for the sensor. Reminder, before you leave the site, don't forget to capture the slope distances, which are the distances from the camera lens to the targets. I will be doing it with a distometer. We advise you to do it with a total station, as it will give you the most accurate measurements. A reminder as well about the accuracy. 1% error on the slope distance will translate into 1% error on the measurement accuracy. Okay. Once our hardware is installed, all of our prisms are set up, the sensor is mounted, we can go ahead and get our first measurement with the Totalite app by running through the wizard. When using the app wizard, we need to find our device from the list of available devices and start the setup. When the setup starts, the app will remind us about all of the steps that we did while mounting the sensor, such as making sure that it's very rigidly mounted and the power is connected to both connectors, the prisms are clean and mounted, and there are no extra reflective surfaces on site that could introduce noise. As well, the app gives us a chance to adjust the power settings given the distance to the farthest target. A measurement will start, and it can take up to 20 minutes before it is completed and will be used for the next step, which is validating the targets that are in the field of view, choosing them, and making sure that there are no targets that are not following the 2-degree angle separation, which will be excluded. Afterwards, we have the chance to name our targets. In this example, we will give them simple names, T1, T2, and T3. This way, we can complete the setup and move to the platform to start creating the baseline from there. Now that we're back to the office and back to Totalite platform, we can finally set up the baseline and start monitoring. I navigated to the project page. This is our node-door garage testing. And now I notice that there is the setup baseline button available under connected devices. I will click that button and the baseline wizard will start. The first thing we see is the constellation, so we can review it with our target names that we set prior with the app wizard. We can click next. We will be prompted to choose a timestamp for when do we want to start our baseline. Normally, the platform will suggest the best timestamp, which is on Wednesday, July 8th at 21:34. We will pick it out at 21:34. We click next step. Now we will be prompted to, if we want, change the name of our targets and set the slope distances, which are, we can give the names here. T1, we can leave it as such, and then we give the slope distance that we measured on site. For us, in this case, the slope distance is 26.13. For T2, it's a little bit closer with 25.5. And for T3, it was 27.2. We can also set the reference target here. In this case, we will choose T3 as our reference target. With the next step, we can create target pairs, which will measure the distance between two targets as a relative measurement. For example, we can choose T1 and T2 to create a target pair, and it will measure the distance between the two of them in three-dimensional space. We press next, we get a chance to review our baseline, and then we can click to create the baseline. And now we have our monitoring setup ready with data that will populate the charts. Once data is populating the charts, we can view it. We have a vertical displacement. We have a chart for horizontal displacement. We can click on the targets to highlight them, zoom in and out. As well, we get our inter-target distance charts with the combined distance and then the vertical and horizontal components. When navigating the charts, we can check the ranges of dates that we want to see, for example, from the 8th to the 9th of July, and it will show us the data for those days. As well, we can have a sampling rate of raw or median of 1 hour. As well, we can export the data in CSV or .json. From the project page, we can as well manage the project, change its name, delete it if we ever wanted to, check the users that are part of the project, and assign new devices if we ever wanted to. As well, by clicking Share Project, we can invite external collaborators to view the project in a view-only user. As well, from the device page, we can see some information about our device, which is device info, what kind of project it's linked to, change the measurement settings, and see the data quality charts with the correlation quality factor, signal to noise ratio, which helps us know about how good are our measurements, and the number of targets that we are seeing. As well, in the device section, we can read the temperature graphs, the voltage, and information about the rotation of the sensor. From Totalite platform, we can as well access the API part, where we can create an API key that allows us to share data streams via API. Please note that the key has to be stored securely, as it will be shown only once and never again.
Let's have a quick chat about threshold alerts. So I have here a freshly set up project, a very awesome one as it is, and a very fresh data stream coming in with displacement data. If I ever wanted to set up alerts and I never did it before, there are two ways to do it. You can either press set up thresholds at the top of the page and a little sidebar will appear, or you can press the set alerts button on the either horizontal or vertical displacement chart itself. And it will basically do the same. A sidebar will appear. Then we have our targets, vertical and horizontal displacement charts, and we can set up target thresholds for each one of the targets. Every target will have a unique threshold for alerts. We can set either starting from 1 millimeter all the way up to 499 millimeters and everything in between. It will set the alert in both, let's say, directions of the chart, so plus minus. Let's say 3 millimeters for T2, we'll have an alert for T2 at plus minus 3 millimeters, and vertical displacement, same for T1. We can do the same in horizontal displacement for T2 and T1, plus minus 3 millimeters, and that will set a threshold. Interesting thing to note is that the data is not being backdated. So at the moment we set the alerts, starting with the next measurement, we will be getting notifications if we exceeded that threshold with a displacement. So given this is a very fresh project, there's little data. So I will take an example with another project that we have, so you can see how it looks with a project that has a little bit more data. Normally the bar on the top, when it's green, it means that no displacement alerts were triggered. When it becomes red, for example, on June 9th or on June 24th, we can check what kind of alerts for which targets were they triggered at what time by clicking the notifications, and then it will bring us to the exact measurement when the alert was triggered. So we have a set of notifications for June 24th, and we can look alerts here. And if you ever want to change the threshold, you can click the set alerts again and just change the threshold for the specific target on the specific chart, either vertical or horizontal. That is pretty much it for alerts.
Okay, guys, starting with you, EPCO. So you're at a party, you're one pina colada down, someone drifts up to you and you need to explain the importance of monitoring to them. What do you say? What's your party summary?
What I will say, and that's after we're not drunk anymore, but then you drive over a bridge, we make sure that those bridges are kept safe. They are getting older, they are moving all the time. We help to decide whether the movement that happens is still okay or whether that's dangerous and something needs to happen. And that is on the spot, or that gives insights on when to renovate it to how do you say that? To make sure that it never goes into the unsafe situation.
Nice. Perfect. And what would you say, Illy, if someone asked you that same question and you had a gin and tonic?
Yeah, so I've been asked that question after a drink before. And usually I would say that we're making sure that both the civil infrastructure surrounding us is being kept safe and is not collapsing. It's basically what Totalite's job is.
Nice. Very succinct as well for party. Epco, what is the current way people monitor deformation that drove you nuts enough that you wanted to fix it?
Yeah, so currently there are multiple technologies, but the market standard on the high end is called a total station or an automated total station. You also see more autonomous tools coming up like tilt meters. But the start of Totalite actually was when one of our customers overnight had 7 total stations stolen, and that is a loss of between 200 and 300,000 euros that got stolen overnight. And then they came back saying, "Can't we develop something that's far easier, cheaper, and does not get stolen?" So it's cheaper equipment, as I just said, but also all the algorithms in the cloud. So if you steal it, even then, somebody that steals it cannot do anything with it because we have the algorithms. The company or the party that stole it needs to announce themselves to be able to use our algorithms. And we know that it belonged to you and not to the one that's coming back with that Totalite. So long story short, the whole starting point was, can't we make something that is a lot cheaper, doesn't get stolen, and if you steal it, they cannot use it. That was the starting point for Totalite.
Yeah. I remember a lot of people at GeoBusiness also saying that it looks so much like a camera that people will be disinterested in it. And it's so compact as well that it can be like caged up as well with just the sensor part unobstructed. And that also stops thieves. So yeah, I mean, that's great design as well.
Yeah, for sure. I mean, from the starting point, everything was designed around that indeed also to make it super compact. And I hope that since we have been in the market, we have not seen a single Totalite being stolen yet. So we assume that will stay.
What's the fastest box to data time that you've actually seen in the field?
I think with a good understanding of what the monitoring setup should look like, the fastest was receiving the sensor on a Monday and having already data by Friday, the same week.
Wow. What are the optimal conditions for that kind of quick installation? Like, what is like the best run through for you?
Yeah, so just getting a good understanding of what are the capabilities of the sensor, of course. So then when you're on site, you can just install the targets, have a good understanding of where the sensor will be, if the field of view is clear enough, and just get clearances to get on site. If everything aligns perfectly, it can go very quick. On site itself, when you just open up the sensor, it can take you half a day to have it installed, and then the second part of the day is already clean data in the platform.
That was awesome. And how does that compare to like traditional equipment normally?
Maybe a better question to Epco.
Yeah. So I think what you explained from Monday to Friday is including receiving the box in your office, unpacking it. Very often our customers are because very often our customers open it there, test it at the office before they go into the field. And then in the field, you need to install the prisms that take time, the bracket where you install the Totalite sensor on. But if you really look to that latter part, installing the Totalite sensor, what we claim on the website has been proven to be true. That part is under an hour, and very often even under half an hour. And if you compare it to a total station, also that part already takes days. So they need to, for total station, they also need to install the prisms. That's what our customers do. They install the prisms. They need to install the automated total station. But installing the automated total station is far more complex. It's bigger. It needs to turn around 360. So it has to be installed even more rigidly than the Totalite. And once it is installed, then getting the whole backend up and running, where there's often separate small software packages connected for compensation, can take for a simple job easily a day. So the part that takes for us 1 hour with the automated total station can easily take a day. And if it's a more difficult setup with really a lot of prisms, especially if there's a second automated total station, it can take 2, 3, 4 days before it's all up and running.
And someone has to be there the entire time as well, don't they?
The full onboarding experience with Totalite sensors, starting from scratch, never having even seen one or touched one, to data is around a week. But indeed, just the installation time is an hour. Within the hour, you have the sensor mounted and data flowing.
That's amazing. That really is amazing. But the difference is very stark.
Yeah.
And then for the actual installation itself, presumably, if you want to set it up in the field and have someone there that can, say, calibrate the device or like move it slightly or adjust the equipment while somebody's in the office looking at the data coming in. So you'd need maybe like 2 people kind of operationally looking at the same equipment, or would it just be done by one person?
I believe it can be done by one person and a couple clicks on Totalite platform for that kind of physical adjustment. The same person that adjusts it can also access the platform and reset the baseline with the same targets, with the same names, with the same slope distances. It's just literally a click of a button.
And that compares to a total station in what, like, is it just one person doing it their side as well, or does it take multiple people?
And mostly it takes multiple people. So depending on the site, they sometimes already need to go with 2 people just for safety and clearance, that they're not allowed alone on the site, but that would apply for Totalite as well. But what you see is very often at our customers, they have one person installing the hardware, so really the physical part, and it's somebody else that is connecting the processing pipeline on the backside. So making sure the data runs through and is actually projected in the platform. Some of our customers, it is the same person doing that, but also quite some customers, it's a different skill set and a different person doing that.
It's quite resource and time intensive then for traditional equipment. I mean, the time savings operationally as well is just huge with Totalite by the sounds of things.
Yeah, absolutely. It's a huge gain. And I think in the whole onboarding to having data in your platform with Totalite, the biggest part of it where it takes time is actually understanding how Totalite is slightly different than a total station. It's still an optical system, but if you really talk about the device, how you plug it, how you get powered on, etc., again, that is an onboarding call that Illy has done already many times in just half an hour. It's more the elements that Totalite is not looking 360 and you have a fixed field of view and you need to position the prisms in a way that they are not too close to each other. These are elements that are new to our customers, and typically that's where most of the explanation is needed, that you get the setup right at the beginning. And the thing that we have not mentioned either yet is that with total stations, they very often have 1 or 2 weeks what they call commissioning time. So even after that time that it is installed, they start monitoring, and then after 1 or 2 weeks, they decide it is good or not good, and they create a baseline at that stage. But they use that commissioning period to also go back every now and then to actually improve the installation. So commissioning is a standard standard phase in almost all the projects of our customers.
What part of the app wizard are you most proud of?
Actually, maybe the whole product positioning. So maybe not one specific feature, but the whole philosophy of why we are doing this app is we want people to go in the field, our customers, without a laptop, which they quite often need to do today. But they need to go in the field without a laptop, could just use a small tablet or their iPhone or smartphone to install it, and the app will give them the security that everything is okay before they actually leave the site. So all your risks that you would have done the setup incorrectly are solved on site. So the moment that you drive back to the office, you have peace of mind. Like, okay, that is okay. The rest is just setting the baseline. And in that sense, you don't need a commissioning period, and you don't need to go back on site again to change things. And that whole design principle, I think, is crucial, and that's where I'm most proud of. Just thinking of what is important for our customer.
Yeah. And Illy, like being so close to the customers as well, you've got an ear to their mouth, as it were. What's the feedback been? Has it made a difference?
Yeah, I think the feedback aligns with the design idea that we had in mind. And we're really bringing something to the field that makes it much more simpler to go from installing and getting data, right? It makes it quick, and it really covers all of the ground needed to have a in the worst case, close to optimal monitoring setup, and in most cases, a really optimal monitoring setup.
That's awesome. Yeah, I really like the way that it really safeguards your experience as well. The fact that you can't move from screen to screen unless you've completed that step properly is like, it's huge. It's so reassuring for people that they've managed to, optimally set up their equipment before they leave.
Yeah, and it makes the data much cleaner for them, and it's good. It's been received well so far.
Yeah. Have you noticed that even on your own setups, that it's a lot easier for you? Like when you're going out in the field and you're setting things up, is it more intuitive now because you've got something telling you that, yeah, I mean, these two targets are too close together, or like this isn't done properly?
Yeah, it really helps, especially with getting the requirement of the 2-degree target separation right on the first try. Usually it would never go well, let's say, on the first try. And now there is just a clear assistance to it that is just there, and it just goes right. You don't need to go back on site to redo things, or you can, if you need to do a modification, you can do it directly on site because the app will tell you, hey, those targets are too close, you need to separate them, and that really helps.
Yeah.
I think one of the really nice proof points for me was last week when Ben, our new business developer, started. And in his first week, he just set up the Totalite with this new wizard, and he ran from A to Z without any question. It just worked. All the steps he was guided through without asking any question to Illy or anyone of our team. Where if we would do that a few months ago, it was already simple, but you would still have some of the nitty-gritty things that could go wrong or got stuck, or where a new person on board would run into. And now he just went from A to Z without question and was set up perfect.
So what mistakes did customers make during setups the wizard now prevents? Like aside from target separation, like what are the big sort of pain points that you've managed to address with this?
I think also noticing the field of view. Sometimes not all of the targets that were meant to be seen were seen, and then it would be noticed later when setting the baseline. So when already leaving the field and having the app telling you, hey, those are your targets, this is what I see, and nothing beside that really helps with that as well on site. So it really brings us to a point where we do it right the first time, and that's a huge improvement.
Yeah.
Yeah, I think apart from target separation and the one that Illy just mentioned, there's a third one, is the LED power, which you're guided through really easily now. So if you have targets really far away at 70 meters, we need to be at 100% of the LED power. But if you have one only at 10 meters, that one becomes overexposed if we crank it up to 100%. and that was, we knew it, and we have some guidance in the user manual, but now you literally see it in the app with a reference to the distance. So customer should not think of how much percent LED power should I put. The customer knows, hey, I've put my target at 50, 45, and just scrolls the bar to 45, and the LED power is adjusted automatically.
Yeah, that's great. That slider function is so nice. I have a question actually, just generally on this, because we make certain statements about the power consumption of the sensor. If it's set to a lower power consumption, does it mean that the battery life also lasts longer?
Yes, normally, yes. If you're connected to a battery, yeah, a lower power consumption of the LED will mean that you're consuming your battery slower. Of course, the measurement frequency as well affects it, so that the more frequently you measure, the more you will consume. The device in an idle state barely consumes any power. It's 0.066 watts, so that's literally nothing.
Yeah.
And but during measurement, of course, it does, and those two settings will really influence the battery life.
And even at the max frequency that we currently have, with measuring every 5 minutes, the battery consumption is already very, very small, below 3. And what you see is you can currently run it over winter with a really small solar panel and a battery, where a lot of the traditional technologies require really big solar panels. The ones that we have lying on the roof as a consumer, you need 2 or 3 of those to run an automated total station network with communication, etc. And now it's just a really small solar panel.
Wow, that's so stunning. Like the difference in power consumption really is huge. That's impressive.
Yeah, I think with a standard car accu, which has around 90 ampere hour, if you measure at 5 minutes with full power, I think it takes you a month to drain the battery fully, and that's a lot.
God.
Yeah, if you reduce the power, of course, and you reduce the measurement frequency, I think it can take up to 2-3 months to drain the power on the battery.
Since this product went live, so from inception to the point that we're at now, what has most surprised you with our technology?
I'll go for a fun one, a very fun answer. So we've been struggling with the previous versions of Totalite with spider webs that would hinder measurements. And since we rolled out V2 with the shield and wiper, the complaints about spider webs went drastically down, close to zero. So that was it's a win. It's definitely a win for us.
Yeah, absolutely. Yeah, in that same level, the other win is how robust it turned out to be in outdoor conditions. So maybe not a surprise in that sense, but it was designed to be robust and reliable outdoors, so that we would not have that much issue with rain, hail, snow, dew, dust. And it was all designed for that. But then it was released on the 30th of September. So the first winter coming up that is in the actual field with your customers is still anxious, so to say. And it went really well. Also, if you look to the previous webinar that we talked about, it was an application in really harsh conditions, and the Totalite performed super good. The same level of performance as the automated total station that was installed next to it. So, did it surprise? No, maybe not a surprise, because that's what we designed for. But are we happy that we actually got those results? Yeah, for sure. Really happy with that.
Yeah, I think Julian also mentioned in that previous webinar, I mean, the temperatures were like minus 20 or something like that. So that's incredible that it withstood those kind of temperatures as well. And that's brutal.
Yeah. The other thing that surprised me was maybe not so much on the product, but every now and then, if I speak to customers, they are requesting a feature or that's already in there that was not completely clear, or we didn't communicate it well enough. Or just 2 weeks ago, I was at a customer who asked for, it would be great if you can find a way in your platform to relate to or to connect through API to the temperature or weather station nearby. And I asked why. He said, because very often temperature has an effect on displacement. So everything moves, and due to temperature changes, day and night cycles, winter and summer, things are moving. And he said, it would be great if we can see that in the Totalite platform. And then I showed him that if you go to device, so the tab with device where we developed basically for remote troubleshooting, you can actually see the temperature graph for a temperature sensor that's on board of the Totalite. And I showed him, I said, I was not aware of it. That's exactly what I want to have. Preferably that same graph as an overlay near the displacement. But he said, this is exactly the information I'm looking for. So sometimes I surprise myself that we are far more feature complete than we tell our customers, or have told them but have not repeated, or that our customers know, which is a nice surprise to have.
Well, have you looked at historical data to see how it's changed over time with climate change and like the fluctuations in weather to see what displacements are taking place?
Every single application is different, but there's one where you can see it really clearly. If you now go to the project in Nodorp, the Nodorp roof test setup, and you go and you look at the vertical displacement graph, and then you go for that same device and you look to the temperature. You see the trend 1-on-1, and that's because it's a metal fence, and metal expands and shrinks with temperature a lot more than concrete. So there you actually do see fences moving up and down, left and right, and you see it very, very clearly. But also the project of George BV, monitoring the bridge in Amsterdam, you see that there's an almost 1-on-1 displacement vertically following 1-on-1 the temperature curve, and horizontally it is with a delay of about 12 hours. And in the beginning, our customer thought that there was an error, because if temperature goes up, you would expect that it expands, and it seemed to be the other way around. And we did research, Nicola did research. And what happens is that the expansion in the length direction of a bridge is so slow that it literally takes a few hours before that heat is dissipated in the concrete, and before you actually, all the way at the end, see the displacement. So they had a bridge which was rigid here and loose there, and the prism was on this side. So it took almost 12 hours before you actually saw the peak of the expansion.
That's really interesting. A lot of people probably notice that same kind of fluctuation in the field and they probably know what to attribute it to, but I think that's really interesting.
Yeah, so all our customers are very much aware of the temperature influence on displacement, on movement. That's almost the first thing they look at. But this was a super experienced surveyor and project leader, and owning a company now, owner of George BV. But the fact that it was delayed was for him new as well.
Yeah.
So it involved all structural engineering information to actually find out that delay was to be expected.
Illy, one for you. What's the weirdest or most remote place you've had to get a sensor installed?
That's I think the most interesting one so far was a moving pier in the UK, and the sensor was monitoring moving targets on a pier that was moving as well, and we were capturing basically the movement of the tidal waves as well. So 5 meters up and 5 meters down, and the sensor was absolutely not designed to capture it in any way. But it was so surprising that it captured it with such detail it was a really a pleasant surprise, let's say, but also a testimony to the fact that we did over design the device in a good way, let's say, which was cool.
So the sensor was in a fixed position and the targets were kind of bobbing up and down.
So not only the sensor was fixed to a floating pier as well.
Wow.
So we were looking at relative movement between targets. Meanwhile, as well capturing the tidal waves movement.
That's a crazy setup.
Yeah, that was definitely not something that we would want to have as a setup, but it was something that really surprised us pleasantly. And the customer also was super happy with the data they got back.
2 projects that I know of that are not as weird as this one, or not so special in that sense, but super interesting because they are prestigious and really nice places. But one was in the monitoring the ceiling of the new train station in Stuttgart. Yes, in Stuttgart, for the German Rail Authority, where we monitoring the ceiling. From the ceiling, they had pathways where the pedestrians and the people will go over to go to the platforms. Those were hanging from the ceiling, and on top of the ceiling, in the middle of the city, they are going to put a green grass and trees on top of it. So the moment that they would load that with a lot of sand, the whole ceiling would come down. But the platforms were not allowed, or the pedestrian areas were not allowed to sink too much, because then they would be hitting the trains going underneath.
Oh.
So they could adjust the bars that it was hanging from. That is a new train station that is still in construction. That was an awesome one. And we had the old library, so a piece of heritage, old library in Delft, which was a really prestigious building.
And what was that monitoring?
That was monitoring cracks in the staircase, and the settlement of a gallery in the centerpiece of the building. I think the weirdest one currently that where it's active is in a culvert in the UK, where if you would need to go back to do something with the Totalite sensor, then you would need to be up to your chest in the water, because it's underneath the rail track, or the HS2, that is in construction, but it's completely filled with water in the meantime. So luckily we have designed a product that you don't have to go back to.
Yeah.
You'd have to like fight amongst you to decide who goes back. It'll be such a, like, everyone would just be volunteering for that one, I think. Very much both for both of your times and answering my questions. We'll follow up after this webinar recording with an email, and that will have links to everything. So that includes everything that we've discussed here. There'll also be a follow-up survey. So if you've got any feature requests that you'd like to see on the device, or as part of our technology offering, you can submit your requests as part of that as well. Also follow up with links to both Illy and EBCO's LinkedIn profiles, so you can connect with them directly. Thank you very much both for your time, and see you later.
Yeah, thanks. See you.
Thank you.